Section 3.1, we're going to look at solving linear systems of equations. So a couple quick definitions. A system of equations is simply two or more equations. That's all it is. So we might have two equations with two variables. Later on in this course we'll have three equations with three variables. We'll see how to do those. A solution to a system is a point which makes all the equations true. Alright, so let me give you an example. Here's a system of equations. Y equals 3x minus 3 and y equals minus 2x plus 7. That's a system of equations. Two equations with two variables. And I might ask, is the point, let's see, -1, -6 a solution? And your answer would be yes or no. Well, the way you would tell is you would take x equals -1 and plug it into the first equation. So if I plug in x equals -1, I get y equals 3 times -1 minus 3. That's minus 3 minus 3. That's minus 6. So that seems good. It works in the first equation. However, to be a solution, it has to work in both. Just working in one isn't good enough. So now we try it in the second equation. Y equals -2 times -1 plus 7. So that's 2 plus 7, which is 9. Unfortunately, it's not -6. So our answer would be no. That one didn't work. Okay, let's try another point. Is 2, 3 a solution? Well, let's try it. X equals 2. When I plug 2 in, I get y equals 3 times 2 minus 3. That's 6 minus 3. That's 3. It works for that one. X is 2, y is 3. Plug into the second equation. Y equals -2 times 2 plus 7. That's -4 plus 7. That's 3. It works in that one. So our answer there would be yes. That is the answer. Now, the obvious question is, how did I come up with that? How did I come up with 2, 3? I knew before I even started that 2, 3 was the right answer because I figured it out in advance. How did I do that? Well, there are multiple ways. And the method we're going to talk about in this section is graphing. So let me show you how you would solve that system by graphing. So I'm just going to do the same problem over again and show you how you would get the answer. Y equals 3x minus 3. Y equals minus 2x plus 7. Okay, to solve by graphing, obviously what you're going to do is you're going to graph. And what's going to happen is, you can see we have one line here with a positive slope, so one line is going to go this way. We're going to have one line with a negative slope, one's going to go that way, and they're going to cross. And what we're really looking for is the point where they cross. Alright, let's put a little scaling on our axes here. Now, what's important in this section, it's important that you use graph paper. It's important that you have a grid like this. And it's also important that you draw straight lines. So a ruler is a helpful thing. Because you've got to have your graphs to be pretty accurate to see where these things are going to cross. Alright, so I'm going to I'll draw this first line in the black that I'm using. And the second line I'll draw in red. You don't have to use different colors, but it does help to keep the two lines apart. Alright, well, this first one's pretty easy to graph. It's in y equals mx plus b form. We know our intercept is 0, -3, which is right there. And we see that our slope is 3. So that tells me if I go up 3, I should go over 1. Up 3, over 1. And I draw the line. And I can do the exact same thing for the second equation. My intercept is 7. 4, 5, 6, 7. I go down 2, 1, 2, over 1. Down 2, 1, 2, over 1. And I can see that those lines are going to cross at a nice place. They cross right there at 2, 3. So my answer would be 2, 3. Alright, let me try another one. How about y equals negative 1/4 x plus 3 and y equals 1/2 x. Again, I'll draw one in black and one in red just to keep them apart. When you're doing your homework, you don't necessarily have to do that. I just like the way it looks. Alright, so again, I scale my axes. Always got to have a scaling. Graphs without scaling are meaningless. Alright, so this time I've got a y-intercept of 3. And I go down 1 over 4. Down 1 over 4. And then I play connect the dots. Now, y equals 1/2 x, on the other hand, I can think of that as 1/2 x plus 0. My y-intercept is 0. And then I go up 1 over 2. Up 1 over 2. And again, I can see those lines are going to cross. I connect my dots. And it looks like those two lines cross at the point 4, 2. Now, it's not a bad idea to check, so I could take 4 and plug it in to each of these, make sure it works, make sure I have the right answer. I'm pretty confident I did it correct, so I'm going to leave it at that. Alright, so here's your homework number 1 problem. Solve y equals 2x minus 6. Y equals minus 3x plus 4. So pause the video at this point. Give that problem a try. Now, some of the problems that you do, of course, the equations might not be in y equals mx plus b form. For example, I might have 2x minus 3y equals negative 6, and x plus 3y equals negative 3. And it helps if you remember alternative ways to graph. Now, one thing you could do, and many students will choose to do this, you could get y all by itself and graph from there. But I'm not going to do that. Here's the way I prefer to graph. When y is not all by itself, I like to find the intercepts. So I'm going to plug 0 in for x, and this is in the first equation here. If I plug 0 in for x, that part's going to be 0. So I divide by negative 3, and I see y is 2. And then conversely, I'm going to flip it. I'm going to plug 0 in for y. If I plug 0 in for y, I have 2x equals negative 6. So x is negative 3. So I'm going to go ahead and draw that line. And connect my dots. Oop, see, I missed a little bit. That's a bad thing. You really want your graphs to be accurate. Notice I missed that dot a little bit. Well, we'll see what we can do here. And then I would repeat the process for this problem. So again, I'm going to plug in 0 for x. 3y is negative 3. Y would have to be negative 1. And then plug 0 in for y. Well, that one's easy. X is already all by itself. X is negative 3. And it just so happens, I get lucky, those two lines happen to cross right at one of the intercepts. That doesn't usually happen. It happens every once in a while. When that does, you're happy because it made your job easier. The answer is negative 3, 0. Okay, so just because y is not all by itself doesn't mean you have to get it all by itself. You can graph by finding the intercepts. Okay, so here's homework problem number 2. Solve. Well, you can't see what I'm writing. Solve. X plus 4y equals 20. 2x minus 4y equals negative 8. So once again, pause the video at this point. Actually, this is going to be the end of this first video. So stop, give this problem a try, see how it goes, and then move on to video number 2.